So can we start now?
Okay, sir. Let's start, sir, so that we can finish in time.
Okay. Okay. So good morning, everybody. You're all welcome. Today we're going to be talking about wireless concept, WLAN concepts. I know we are all familiar with wireless network, but then we still have to go through some theoretical parts here in chapter 12. Then in chapter 13, it's all about practical session. So I'm going to use packet tracer to demonstrate the wireless, building a simple wireless network, and also the one with wireless LAN controller. But then before then, let's talk about the concept first. So we have two chapters to take care of today, 12 and 13. So we're going to talk about introduction to wireless, components of wireless LAN, wireless LAN operation. We'll talk about CAP/WAP operation, channel management, wireless LAN threads, and then secure wireless local area network. So let the journey start. Introduction to wireless. Benefits of wireless. So what is a wireless LAN? A wireless LAN is a type of wireless network that is commonly used in homes, offices, and campus environment. I'm sure we all know that. Probably we are all connected to wireless network. Like I am using my laptop and I created hotspot on my phone, and I connected wirelessly to my phone. So the advantage of wireless is because of the mobility. Wireless LANs make mobility possible within the home and business environment. So you are not tied down with cable, even though wireless has its own disadvantages. It depends now, because if you are on Wi-Fi 6, there's some limitation that have been eliminated already. But if it's the old school Wi-Fi, some of those limitations are still there. Wireless infrastructure adapts to rapidly changing needs and technology. The technology for wireless is always increasing, improving, and advancing. For instance, the way wireless operates basically is more or less like half duplex. But with Wi-Fi 6, they've tried to make wireless behave like full duplex, and that is a major breakthrough for wireless technology. But if you don't have Wi-Fi 6 on your network, you're still going to be going through the limitation of probably the regular Wi-Fi you have. Maybe they call it Wi-Fi 4, and so on and so forth. So they're always advancing. Also in security, because these are the challenges we have with wireless. Security is one major problem with wireless. Because if I come to your environment, I don't need to enter into your compound onto the school environment before I can see a wireless signal. Even if you had your SSID, it will still show me that there is hidden network.
Yes.
And we can probe it with software to give to us the real SSID. And when you talk about wireless network, there are different types of wireless network, different types, depends on the range. The first one is wireless personal area network. This is low power and short range. For instance, when you use your Bluetooth to connect phones together, Bluetooth to laptop, phone to laptop to using Bluetooth, or laptop to your player using Bluetooth or Zigbee, these are called wireless personal area network. the range is between 6 to 9 meters. Even though there's a new technology for Bluetooth, I think it's Bluetooth 5.0, they go beyond these 10 meters. Then we'll also have wireless local area network, and that is the one we use on campus most of the time. Medium-sized network up to 300 feet. And it is based on IEEE 802.11 standard. I think I skipped that here. For Bluetooth, this is the standard for Bluetooth, 802.15 standard, and it operates on 2.4 gigahertz frequency. We're going to talk briefly about these frequencies. You know, anything wireless is all about frequency. Wireless is all about frequency. So we need to know the standard for the wireless personal area. And also we need to know the standard for wireless LAN, because that is the one we are concerned with mostly. But we use most of these stuffs on our LAN. So this medium-sized network is up to 300 feet based on IEEE 802.11 standard. So for wireless LAN, the standard for wireless LAN is 802.11, even though we have 802.11 in different variants. A, B, C, A, B, then D, and G, and N. We are going to see them as we proceed. And for our wireless LAN, it can operate on 2.4 gigahertz frequency or 5.0 gigahertz frequency. Now, we said this cannot go beyond 300 feet. So what happens? How do you have wide coverage all over on campus? That is why you do roaming. You have multiple access points and make sure there is what's that thing called? Let me try to remember. When you make sure that this, the area of coverage intersects, there's a terminology they use for that. Where you don't live, so that if I am coming from this side, I can move to the other access point without losing connection. So you cannot deploy access point in such a way that if I'm coming from this side, I have a blind spot here and I'm totally disconnected before I can reconnect again. There's a word they call this, the terminology
Is
they
it
use.
handover? Is it handover?
No, it's not handover, they call it.
Or handoff?
It should be handoff.
No, I know that when one access point hands over to the other, that's called handover. But the design is what I'm talking about. When you make sure they intersect, there's a word for that. So, you know what I'm saying is, let's say, let me clear this. Let's say this is AP1, the first AP, the second AP. If the coverage of this AP is here now, and I go and put another AP somewhere, and the coverage is here now. So if somebody is coming from this place, by the time the person gets to this middle here, the person will lose connection before you can reconnect again. So in order for this person not to lose connection, we placed the AP in such a way that their signal, their area of coverage intersects.
Okay.
If I remember, I will tell us well before we finish. So that when I get here, before I'm handed over to the second AP, I don't lose connection. Especially if you configure all of them with the same SSID. And that is the best way to do it. But once you have different SSID, there's going to be a brief disconnection and then reconnect again. So if I remember, so that's the design for mesh. When I say mesh, I'm not talking of mesh in the sense that there's a way people use mesh and the design is different. But I'm talking of mesh in the sense that you have multiple access points littered everywhere so that you can have coverage everywhere. Because most of the access points can't go beyond, is it 30 meters or 100 meters? I think it's 30 meters or so. Most of them on local area network. I think it's 30 meters. I can't remember. I will confirm that. So we need to be aware of that. Then we have wireless MAN. Wireless MAN is Metropolitan Area Network. Large geographical areas such as city or districts, it uses specific license frequency. So it depends. Let's say now, university, yes, sir?
It just went off momentarily, like the American States, but it's fine.
Okay.
Following.
Let me know once I'm off.
Okay.
I will try to load my Airtel against tomorrow's class so that I can switch in between, because I don't know if it's from my home hand or from your hand. We had this issue yesterday too.
Yeah.
You can hear me now.
Yes.
Okay. So let's assume now university, you have main campus, And then somewhere you have another campus somewhere, maybe separated by, let's say, 40 kilometers, 50 kilometers, or something like that. So um, let's say word I just keep my mind now, when you have like a branch, they call it what? There's a word they put for it, something campus.
Campus area network.
I know, like if it's your main campus now, you have a branch somewhere, maybe where students can also have
Mini
lecture,
campus.
and something like mini campus, but there's a word I'm looking for. So now, what if we want to connect, we want to extend the connection from main campus to this other mini campus? So we can set up an access point here. There will be a dish that will face this other one, a dish on the other side also. There'll be an access point here. There'll be an access point here. This is called point to point. So we're going to link these two campus, these two campus together, the meaning to the main campus. So what we have established in this scenario is wireless metropolitan area network. Some banks also do this. In a city, they will have the headquarter in that city. Then they will have branches also, same bank in other area in the city, but far away. So what they do majorly is they link all those branches together to the headquarter through wireless network or wireless technology. So that is what we call wireless metropolitan area network. When you connect within a city or within states and you link branches together or different locations together, that gives us wireless metropolitan area network. And we also have wireless wide area network. That one, like I am in Jos, you people are in Abuja. What if we want to link University of Jos to now invest in Abuja? Is it possible? Of course, it's possible because there are radios now, access point that can cover up to 300 kilometers as long as you have line of sight. So we can have Nile here and have Uni Jos here. Maybe you will have things to do together. We can decide to link ourselves together as long as we're able to have line of sight from Jos to Abuja. And that is a good example of wireless wide area network. But it's beyond this, what I just explained now. But you just need to have an idea. So wireless technology comes in different ways. These are just the basic one you need to be aware of. So we've talked about Bluetooth before. So look at what I said earlier. They said Bluetooth can cover 9 meters. The recent Bluetooth standard now can cover 100 meters. And that is amazing. They are also advancing on the technology, Bluetooth technology. I think it's 5.0 or so. I can't remember the Bluetooth, the version of the Bluetooth. So with Bluetooth, you can even form a local area network. So you can connect multiple phones together with Bluetooth. So Bluetooth technology is really advancing. That's why people will hear, they wear earpiece and far away from their phone, they can still pick calls, they can talk. And that is wireless technology for you there. So it is IEEE WPAN, that is for personal area network standard, is used for device pairing and up to 300 feet, 100 meters. That is for Bluetooth. Bluetooth low energy support mesh topology to large-scale network devices. I have never demonstrated it, and I've heard that it's possible for you to use Bluetooth to link multiple devices together. And of course, it can support point-to-point topology and can be optimized for audio streaming. These are capabilities of Bluetooth. Then we also have another technology here, which is called WiMAX. WiMAX is not that popular here, but it's becoming popular gradually. It is an alternative. The full meaning is worldwide interoperability for microwave access. It's an alternative broadband wire internet connection. And look at the standard here, 802.16 wireless LAN standard, and it can cover up to 50 kilometers. Now, the beauty of WiMAX is what I read about WiMAX. By the time okay, let me explain. Yes, Mr. Dekule, you have a question. Please go ahead. Go ahead. Yes, Mr. Dekule. Hello. Can you hear me?
I think his mic is
Okay, he's
not connected.
asking a question here, or
Yes.
he's giving a suggestion here. Let me read and comment on that. I think instead of using wireless access point for connecting two different campus, I think the use of radio is better. When we say wireless access point, we are saying the same thing as radio.
No, okay. So I actually think if he's listening,
Yes,
I'm
I
thinking
believe it.
a
If he
microwave.
can't,
I
yeah, if
think
he cannot
a
talk, he
microwave.
can type.
I think he
I'm
had
thinking
you.
that
Probably
a
just
microwave link.
misinterpreted
No,
radio as another thing.
I'm thinking a microwave link would
Yeah.
do a better job of linking two campuses together.
Okay, maybe that's what he's talking about microwave, right?
Yes, I think so.
Just say the radio, which is still an access point.
It's still an access point, but if you want to
Yeah,
go,
radio is an access point.
higher, you can use microwave. You know, microwave is more expensive. It's more
Yes,
expensive than regular access point. Very expensive. So nowadays, for instance, now Ubiquiti will have access point. And by the way, doctor, I sent the link of that story I spoke about yesterday to this group on
oh, okay.
the Union Bank issue that happened some years ago.
Oh,
Maybe a
okay.
little this week.
I thought it was a lecture recording, but I will check it now.
Oh no, I sent lecture recording and I also sent that link now. I saw
Okay.
it on. I went and searched for it online.
Okay. Thank you so very
Yeah.
much.
So this is it. Ubiquiti, for instance. I believe do you use Ubiquiti in your university? Access
I
point.
don't know, but I've used it before. I even used to sell it.
Okay. Ubiquiti they have gone way crazy with wireless technology when it comes to point to point. They have the one that can cover. So the last time I went to their site to check for stuff like that, up to 300 kilometers
Wow.
and affordable. You know, these people they killed people like Cisco when it comes to wireless technology.
Cisco
Very
is,
affordable and simple to configure, set up,
and
flexible, perfect, give perfect signals.
IRRUS as a wireless point access about 10, 15 years ago, and with three points, three access points, you can cover an entire campus, like our main academic.
You see what I'm talking about. So instead of me to go for microwave, if Ubiquiti that can cover 300 kilometers is available and is very, very affordable, why would I go for microwave? So we can, it all depends on the cost and the technology. If it's available out there, I will use it. So, but when I say access point, I'm still talking about radio. I hope Mr. Adekunle is listening. You can respond to that if you are clear with this.
It says,
Okay. Yeah, so you can go for microwave if uh you don't have this solution. But if this solution is there, you just go for this access point, this radio. I mean, Ubiquiti's Pro. I think some other people prefer Rokus. Prof, do you know Rokus too? Like in Covenant University, they use Rokus.
Yes, I
They were
do.
using Ubiquiti before. They went to see Rokus. I don't know if I get the spelling right. Rokus. They, from their own experience, they discovered that Rokus is more it can withstand pressure more than Ubiquiti, especially when you have one access point in a conference hall that can take like 1,000 users without shaking. So they discovered that Rokus is better than Ubiquiti. But for point to point, if you can still use Ubiquiti, but Rokus is very, very expensive. So are we good?
yes.
Okay. So I was talking about WiMAX. What I read about WiMAX, a time will come, I believe, when most of these telecom industry, MTN and the rest of them, will not be having as many as tower they used to have in the cities. Because instead of them dropping most of this tower all around and putting all their equipment everywhere, they will have few WiMAX masts. This technology, because of the coverage, The reason why you have too many masts everywhere is because the coverage of the wireless technologies, they need to roam and roam and roam and roam so that it doesn't matter where you are, you can see their signal. So with wire mast technology coming, or is there already, but a land that is still very expensive to deploy, they may have to replace most of what this their masts with wire mast technology. And maybe in a city, you end up having just 2 masts or 3 or 4, and they'll be able to cover maybe a whole city or something like that. There are wire masts that can go beyond 50 kilometers. You can research this. I even read that, I don't know which standard is that one for wire mast. There are some the wire masts that can cover like is it 2 or 3 for the whole country, and any wireless anything you beam like this, it beams everywhere in all directions. So that's another wonderful technology that is coming up there. It's out there already, but I heard that it's still it's expensive to deploy for now. But we need to be aware of this. Of course, we are used to cellular broadband. That is what we have for our GSM. It could be based on GSM. It could be based on CDMA. We were using CDMA before. Our multi-link, I think they were using CDMA before they got knocked out. Yeah. And of course, you have your satellite broadband. Like people that use Starlink now. Some people are beginning to move to Starlink. Even institutions are beginning to move to Starlink. It's satellite broadband. And it gives you wonderful speed of up to 200 meg. 200 Mbps, even beyond that, depending on the one you purchase, residential, business, or what have you. So that is the beauty of satellite technology. Now, but back in those days, satellite can give you more than, is it 1.5 Mbps or 2.5 Mbps? I can't remember, but the speed is not something you can be happy about. But now, Starlink has changed the game.
Okay.
You said, Prof?
We didn't hear you for just 30 seconds.
Hey, now wow, this is my network. Cool. So I was talking about Starlink. I say Starlink is a good example of satellite broadband.
Okay.
And the speed it gives, you can give up to 200 meg, 300 meg.
Okay.
And some people are beginning to move to Starlink because this is cheaper. In a month, you pay like approximately, is it 40,000 or thereabout to get 200 meg. You can't get this from MTN or Airtel. You pay through your nose to get this speed. At least I'm aware MTN, for MTN to give you 10 meg, you are talking of almost 400K or more monthly. But you get almost 200 to 300 meg with Starlink and pay 40,000 naira monthly, equivalent approximately. And as long as they're in your country, you can get that signal anywhere. That's the beauty of satellite. They even have the one for ship. They have the one for cars that you can mount on car. Now they are talking of the one that you can put on plane. So that anywhere the plane is going to, you can browse. As long as you have line of sight to the satellite in the space, you are good to go. Am I communicating, sir?
Yes, yes.
So this is the one we are concerned with mostly because we are more of land people. We do deployment of wireless on land. 802.11 standard, that is for our wireless LAN standard. It defines how radio frequencies are used for wireless links. So we need to know the different standards that we have, the frequency they operate on, and the description of the standard or the speed. For instance, this journey of wireless LAN standard started from 802.11. It runs on 2.4 gigahertz, and look at the speed of wireless back in those days. Starting point. Then they moved to 11.11a, 5 gigahertz. Then the speed increased to 54 megabit per second. And you know the problem with wireless. If you have 54 meg on access point, let's say you deploy a particular access point now, and it supports 802.11a. That means this is the speed that access point can support. If 54 people connect to this access point, they are going to share this speed. It's like a plate of food. All of us gather around it, we are going to share it. Unlike a switch, if you are plugged to the switch, you have a dedicated bandwidth to yourself. But on wireless network, you don't have dedicated bandwidth to yourself. All of us will share the speed of that access point. That's why when you hear people talking about upgrade, wireless upgrade, what they are simply doing is they are migrating or moving from one standard to another standard to another standard to another standard, just to increase the bandwidth so that they have more speed for the users on the network. So we can see they also move to, or let me say, they also have 802.11b. So what is the problem with this 802.11a? They said it's not interoperable with 802.11b or 802.11g. Why do you need interoperability? If your access point is designed based on 802.11a and my laptop is designed based on, let's say, 802.11b, my wireless card cannot connect to your access point because they are not interoperable. So the standard must be the same or they must be interoperable. Because I want to connect to you as access point. You are going to give me access to the network or access to the internet. The standard you are running or you are built on and the standard my card is built on, they must be compatible or they must be the same. So that's why we need to know about this interoperability issue. So they have 802.11b. It runs on 2.4 gigahertz. Look at the speed here. It can cover longer range and it's able to penetrate building structure. That is one of the advantages of 802.11b. But then we've gone beyond this now, in our age now. Now we're talking about 802.11g. Look at the speed here. And it's backward compatible with 802.11b. We also have 802.11n, which runs on 2.4 gigahertz and 5 gigahertz. It can support the speed of 150 meg up to 600 meg. And it requires multiple antenna with MIMO technology. What is MIMO? Multiple input and output. Multiple input and output. When you see some access point that have multiple antenna, the reason why they have the antenna is because they want to kind of allow multiple users to connect to the antenna, the access point simultaneously. So you can have multiple people coming in, multiple people going out. With that, they can increase the performance of the access point or of the wireless network, because you have multiple antenna. This is more or less trying to say, make it look like we granted you a dedicated connection to the access point as a user. So you could have maybe 5 users simultaneously or 10 users simultaneously. Then you also have 802.11 AC. It runs on 5 gigahertz. Look at the speed it can support, up to 1.3 gigahertz. Gigabit per second. Can you hear me? Hello, sir. Can you hear me? Can you hear me, sir? Ahmed, can you hear me? Hello? Okay, that should be from my hand. Sorry about that. I just bounced the network.
Okay, we can hear you now. I can hear
Okay.
you.
Okay. What about Prof? Can Prof hear me too?
Mr. Adekunle, can you hear?
Hello, Prof. Can you hear me? Hello. Hello, Prof. Mr. Adekunle, if you can hear, can you please let us know?
I think you just left the meeting to connect back. Maybe they have issues with with the network at the side.
Okay.
Maybe give them. Yes, I can. Okay, Prof is trying to reply you, so I think the network is from his own side.
Okay.
We're not hearing you in the last 1 minute, sir.
Yes, I have to restart my network because once all of you are not hearing, that means it's from my own hand. So I hope it's okay. It's better now. Prof, is it okay now? Hello, Prof.
No, I'm not. I can't hear what you're saying, sir.
I said I had to restart my network. I
I'll just try and join. I'll just try and use another.
that means the
service.
the poor network is from my hand. But are we good now? Hello, Prof. Are we good?
No, not good though. But
Okay.
I'm joining another. I'm joining with another device now.
This is one of the challenges with online training. Sometimes network can be erratic.
Yeah, I can see my phone is working, so I'll just join. I'll join. I'll put.
Okay, we continue on the phone.
I don't know why the school like this will not have good network. It's a big problem.
Maybe you people are managing service provider, as in you probably who's supplying you people the internet?
I think my own phone is working too. Hello, are you hearing me now, sir?
I can hear you, Prof.
Okay, let me see.
Connection has been good for all this while. So are you using the wireless?
I don't know whether I've connected. I need to move to one. Are you still hearing me, sir?
Yes, sir.
So if you are using the wireless in the school, I think it's the one from 20. If you can connect to the cable and turn off your wireless adapter, probably it will be better.
Hello?
Yes, Prof.
Hello, everybody.
Can you hear me? Hello, Prof. Can you hear me?
Hello?
Mr. Ahmed, can you
Anybody
hear?
that is hearing should answer me.
Hello, Mr.
Prof,
Ahmed, can you hear me?
Prof,
Yes, sir.
Problem is that the other people are not just responding, and I don't know why. And I can't unmute. I don't know where this one is coming from. Can't unmute. Very difficult to unmute on my phone.
okay, let me. So I'm to input for all this way. So are you using the wireless?
Eh? Ahmed, what did you say? Where is this?
Hello, Prof, can you hear me?
Just go out and
Hello? Hello, Prof.
So Ahmed, okay, I've gone out and come back in. I hope it works now. But I'm still not hearing anything.
I can hear you now, sir.
Okay, I can also hear you clearly on my phone.
Okay.
So maybe we should continue. But the other people, I didn't hear you. It's so quiet.
Ahmed has
are you
been
hearing
saying he
me?
can hear.
What of Mr. Taiwo? I think he's on now. Thanks, Mr. Taiwo. Okay. So I think we can just go ahead, please. The
Okay, sir.
computer, I think the computer is one that is having issue. So, but I can hear you and I can see your screen on my phone.
Okay.
So I think we should just continue.
Okay, sir. Okay, so the next, okay, this is where I left off before we started having issue. You need to log out one of the devices. It's echoing back to me.
No problem. I will just do something.
Or mute.
You can go ahead, sir. Go ahead.
All right. So when you purchase access point, or when you are planning to purchase access point, you should be able to determine which of the standard the access point support, because that is what will determine the speed. That is the bandwidth of that particular access point. So because if somebody just come and deploy access point of let's say 802.11g that support 802.11g, it is way different from somebody that is deploying 802.11ac or 802.11ax. So we need to be aware of all of these things. And of course, you need to also know the frequency. Is it 2.4 gigahertz or 5 gigahertz? The difference is always in the coverage. I think one can travel further, the other one can penetrate. I always mix it up. We should be able to see it inside the slide here. So you will have to be in charge of, okay, this is what I want. I want so standard, and I want it to be on so frequency. Yeah, I think so. So when you talk about frequency, there are different frequencies out there, but the one we are concerned about is our 2.4 gigahertz and our 5 gigahertz. We can see 2.4 gigahertz here. We call it UHF, that is ultra high frequency, and then the 5 gigahertz is super high frequency. So you can see the standard that support 2.4 gigahertz, and we can also see the ones that support 5 gigahertz. So you should know what you want. You should be able to decide what you want. And so many things run on different frequencies. You can see we have radio here, we have microwave here, with the wireless devices here, all kinds of stuff. Even this one looks like the remote. They have different frequencies: infrared, red radio wave, ultraviolet, X-ray, gamma ray. These are different stuff that run on different frequency. But our own concern is on our 2.4 gigahertz and our 5 gigahertz. Then when you come to wireless standard organization, who are the people behind this standard? You must have talked about this briefly in CCNA1. You always have to talk about your ITU, that is International Telecommunication Union. They regulate the allocation of radio spectrum and satellite orbit. And of course, you must have talked about IEEE, which they specify how a radio frequency is modulated to carry information. These are bodies behind most of the standards we have. They are going to be in charge, or they are in charge to be able to determine what happens or how these things are rolled out. And we also have Wi-Fi Alliance. It promotes the growth and acceptance of wireless LAN. It is an association of vendors whose objective is to improve the interoperability of products that are based on 802.11 standards. So different standards are supported by this organization. We need to be aware of all of these organizations. So that is that. The main part we are going now is to talk about the wireless components. So I hope we are cool with this part before I move on, and I hope you can hear me clearly, sir. Prof, are you with me?
Yes, I'm managing to combine two systems.
Okay.
But one of the things I want to add, suddenly start working.
I'm with you, sir. Yeah, Prof, you are saying something.
So what I'm saying, sir, is that I'm not sure I understand. Keep quiet.
Yes, Prof.
So what I'm trying to say is that the 802.11G, well, the one that goes on 5 megahertz, I think you have to pay for the frequency. So I guess that's one of the disadvantages. Are you hearing me, sir?
Hello, Prof.
Yes. Are you
Please, can
hearing
you
me?
repeat the question again?
It's just a comment. I'm saying that it appears to me that
I thought as much.
It appears to me that the 802.11G, that's the one on that gives 54 megabits per second and on 5 megahertz. It looks to me that you have to pay for that frequency.
No. All this one you see here, you don't pay for any of these frequencies. Once you buy the access point, these are frequencies that are given free for this access point.
I see. Okay.
Yeah, these ones are free frequencies that are free to us. It's just for us to buy the equipment, we install, and we're good to go.
Okay, sir.
Yes. Are you clear, sir?
Yes.
Any other question?
That's all from me, sir.
Okay, any other question from any other person? So, Prof, let me ask a question out of curiosity. Why did you stop selling these radios now?
I moved to public service.
Okay.
Yes. I was not only selling radio, I was doing serious networking. I happened
Installation.
to be one of the first set of people that actually were installing installation of fiber optic cable.
Wow.
All these multi-links, the VGC communications, motor phone. Those are the people that Bata wanted to give GSM to, and it actually worked in Lagos, Abuja, and Port Harcourt. I actually helped them set up their fiber links. So
Wow.
I used to be a professional. I used to be a professional, but I've since stopped that.
And this is one of the reasons why this lecture course is easier for you to grab, because if you don't have some of these experiences or passion in things like this, all these things we are talking, it should just look as if we are just talking above the head of,
True. I'm
yeah.
very interested.
Yeah.
I'm
So that
hugely
passion
interested.
is really helping you.
Yeah. Thank you, sir.
Because that's a good one. From our experience in training, when you go to some universities to go and conduct training, they'll pack all these organs there. Give them 1 week, they've all scattered because they cannot cope in the class.
I don't do that. Even when I was in the public service, I was actually one of the first persons to take level 10, level 9 to travel, because I was supposed to be managing an IT department, and the guys want to go for training. And I asked them, "Are you going to be able to sleep in the office?"
Mm-hmm.
And they said no. But they said the junior one will run away. I said, no problem, they won't run away. So I put the name of the secretary of the commission. to make sure that the junior ones don't run away. Yeah, nobody will run away. So I believe in the junior ones, and you see these people that we have, they are carefully selected also to be here. And even though I think Opeyemi may be on transit, but I can assure you that they know their responsibility. Those who have to watch video, they will watch it, and they will do all the assignments.
That's a good one.
They were carefully selected, and they're the people who know what they want.
That's a good one.
That's a good one.
Yeah. You're welcome, sir. All right, let's quickly finish this part so that we can go to labs. So wireless component, briefly, let's talk about wireless component. The first one on the line is our network card, wireless network card. Because we always use computers, phones, tablets to connect to the wireless network. If you don't have a wireless NIC, whether it is visible or inbuilt, you can't connect to the wireless network. So to communicate wirelessly, laptops, tablets, smartphone, Prof, you need to log out of one of the devices. It's echoing back. Hello, sir.
Yeah, I think that maybe if I just mute.
Or you mute. Let's see if mute will work. Can you hear me, sir?
I've just connected one of the devices to earphone, and I think as long as I mute, it will be fine. I think it's fine now.
It's fine now. I'm not hearing the echo again.
Okay, you are not hearing me.
No, I can hear you, but the echo is not there again.
Yes, because I've connected an earphone and then I've muted. So it should be fine.
Sir.
Yeah, thank you.
It's okay, sir. So to communicate wirelessly, laptops, tablets, smartphones, and even the latest automobiles include integrated wireless network interface card that incorporate a radio transmitter and receiver. That's all you have in your wireless card. It can transmit, radio transmitter, and receiver. But if a device does not have an integrated wireless network interface card, then a USB wireless adapter can be used, like what you see in this place now. And sometimes it's not because the device doesn't have the inbuilt card. Maybe the inbuilt card is gone bad, or the capability is not that strong. You can decide to go and buy external wireless network card that is stronger, and you begin to use it that way. This is number one wireless component we need to be aware of, non-negotiable on any of our devices. Even your phone has inbuilt wireless, inbuilt antenna, which is more or less like our wireless stuff to connect to the cellular network. Others have wireless home router. A home user typically interconnect wireless devices using a small wireless router. Wireless routers serve as the following. We call it 3-in-1. Why do we call most of these home routers 3-in-1? It can function as access point. It provides wireless access. That should be. It can function as a switch. It can connect wired devices wireless with wired. And it can also function as a router. It can provide a default gateway to other networks and the internet. So most of the time you see this device, we call this device 3-in-1. Because it's a router, it's a switch, and it's also an access point. It can play all these roles. Home routers, most of the home routers nowadays, or wireless home routers, are just like that. Then they come in different capacity, depending on the CPU, depending on the RAM, and so on and so forth. Now, depending on the kind of traffic you have in that environment. Then we also have some other access point that we can use for point-to-point, or even you can use for business environment. Wireless clients use their wireless NIC to discover nearby access point. Clients then attempt to associate and authenticate with AP. After being authenticated, wireless users have access to network resources. This is an example of an access point. This is Cisco Meraki access point, even though it's not popular in this environment because it's cloud-based access point. Most of the Meraki stuffs are cloud-based. But people have dedicated access point, which we call autonomous access point. We're going to talk about those ones too very soon. That you can install, inject internet connection into the access point, and then you connect your users or the clients to the access points. And we're also going to do this practically. So when you connect the client to the access point, what happens? The first thing they do is they associate. They try to associate with the access point, front and back, front and back, front and back. After that, they now authenticate. Because if you don't know the password that is on the access point and tell the system about the password, there is no way the client will be authenticated to or be granted access to join the network. So there are different categories of access points. When you talk about access point, you can categorize them into two. We have access points that are autonomous access points, meaning they can stand alone. And then you have the one that are controller-based access point, meaning they need a controller to give them their configuration before they can work. And those ones are also called lightweight access points. See them here. The autonomous AP, standalone devices configured through a command line interface or GUI. And we're going to configure one autonomous AP in this class today. Each autonomous AP acts independently of the other and is configured and managed manually by an administrator. You can see an example of autonomous AP in this place here. Then we have the controller-based AP, which is also known as lightweight APs. This one, they use lightweight access point protocol to communicate with lightweight access. No, what is this one? L1 controller. I know it as wireless LAN controller. I think I'll find out this place. Each LAP, that is lightweight access point, is automatically configured and managed by the wireless LAN controller. We are going to also do this one. Look at the controller here. Look at the access point here. This access point cannot work. It has to import its configuration from this controller. And in most institutions today or campus network, people don't use autonomous AP again. They use controller-based AP. What is the advantage of controller-based AP? It simplifies your job. You can keep on adding access point without having to configure those access points manually. They just go to the controller and pick up their configuration. And from the controller, you can manage all the access points. You can see all your access points. You can see all the clients connected to each of the access points. And if any access point is down in any location, you can find out from the controller. Prof, can you still hear me? I saw that you logged out.
Yes, I can hear you. It looks like I have just established that it's our internet that is causing problem.
Okay.
So I just I got out of our internet.
Okay.
To just focus on my phone.
Okay, maybe you people need to consult us. Let's come and give you good internet connection.
That's why you should come. I think the problem of our internet may be internal. I think the problem of our network may be internal distribution rather than external.
Maybe the design. Maybe the design.
Yes, there's no design.
But what's the size of your bandwidth?
I don't know now. Some big people are the ones in charge.
And then we need to also know that possibly the bandwidth you have is not enough for the numbers of students on campus. And then you people do bandwidth management because students are just like vampires. You don't do bandwidth management, they consume everything.
That's what I expect them to do, and I advise them that they should actually give a specific amount of bandwidth to each student and staff, so that when you finish, then you know that you finish your own, and maybe you can buy or go and be using your data.
That's what they do in conventional university.
That's
they
what they
allocate
also do in
bandwidth
this.
to users.
Yes, that's the best thing. Actually, that's the best way to manage it, if you ask.
Yeah. Okay, so let's move on. We'll soon. I can't wait to get it.
I'm cool now. I'm cool now, and I think going forward, I'll just rely more on my devices rather than this internet.
It's okay, sir. Let's talk about wireless antennas. You have different types of antenna. You have omnidirectional antenna. This is the omni. It can face 360-degree, meaning it can beam signal in all directions. You have directional antenna. Look at directional antenna here. It just focus on one side. An example of that is parabolic dish or Yagi. This directional antenna can travel further than the omnidirectional. And then you have multiple input and multiple outputs. These are multiple antennas, like I explained with some of the access point. The reason for this is so that you can have simultaneous connection to the access point as if you have a dedicated connection. And that can increase the bandwidth. Bandwidth in the sense that multiple users can have access to dedicated connection using these different antennas. Not because it's going to increase the bandwidth of the radio or the access point. It's just going to have more love. You are not sharing, because once you connect to a particular antenna, you are the only one using the antenna at that point in time. So these are different antennas, majorly directional and omnidirectional. There are others, but I don't think they are here. They are not in this place. But you need to be aware of that. And when do we really talk about this? Directional, when you want to do point to point. Point to point. Most of the point-to-point connection, they always use point-to-point directional antenna. But most of the access point that people deploy in on campus and all, their antenna is always omnidirectional. So when you mount it on the ceiling facing down, it can go 360. Anybody within the range of the area the access point can cover, they can receive signals from that. So these are different antenna, and you don't see the antenna physically in most of those radios or the access point. They are inbuilt. It's like your phone. Your phone has an antenna, but it's inbuilt. Back in those days when people started using phone, you are going to have to bring out the antenna. When you are done talking, you talk it back in. That was before antenna became powerful. Then now you can have small antenna and it's inbuilt, and you can still pick the signal regardless of your location as long as there is signal in that area. And it also depends on the strength of that antenna, because antenna comes with different capability. That is another thing we need to be aware of. So that's that on wireless antenna. Okay, so let's talk about wireless LAN operation. Different ways to connect to set up a wireless network. The first one is ad hoc. What is in ad hoc? You can connect two clients together without an access point using their wireless card. You don't need an AP. They can connect together. It's just like when you connect phones together using Bluetooth and all of that. So we can use the same wireless network card on these two systems to link them up. This is more or less like when you do peer-to-peer with network cable. So when you connect two wireless laptops together directly without an SAP, that is called ad hoc mode topology or connection. But once you put AP in between, that is called infrastructure mode. So you use access point to link all those devices together. So in this scenario right now, your access point is more or less like your switch that aggregate wireless connection. The access point is more or less like your switch that aggregates the wireless connection. And now this is another one they had. This wasn't in the curriculum before. Tethering. We do tethering a lot on phone. Sometimes we call this hotspots. See, the phone is getting internet connection from maybe MTN, Glo, or whatever. And I can also activate hotspot on my phone to give internet connection to my laptop. But when you connect cable directly, because that is the way it works on my phone, hotspot won't work for you. I have to go and select tethering. So I collect the signal wirelessly and I'm giving it to my laptop through USB. That is the way tethering works for me. And most of the phones I have seen. But the way they kind of explain it here is as if it connects wirelessly. That is hotspot. So two options on the phone. When you create hotspot, it connects to the computer. But when you want to connect with a cable, you have the internet connection through cellular, and you want to connect with a cable, you got to go and select the tethering option, and then the internet connection is injected into your phone. So still talking about the operation of wireless, these are terminologies we need to be aware of: BSS and ESS. Infrastructure mode defines two topology blocks. Infrastructure modes defines two topology blocks. So when we configure, when we set up a wireless network with access points, this is one of the terminology we need to be aware of. The first one is basic service set, BSS. What is BSS? BSS basically is, how do I put it to you now? Okay, let me just read this. Uses single AP to interconnect all associated wireless clients. Clients in different BSS cannot communicate. Okay, let me put it to you. When you set up SSID or a wireless network, that's the better way. When I set up a wireless network and I define my network name, that is more or less like the environment where I have my network, where I have that coverage. That is my basic service set. I have set it. That's my wireless environment. Another wireless environment or wireless connection in another area cannot come and connect to me. Why? Because we have different SSID or we have different network name. We can't link them all together. Sometimes some of this terminology can be confusing. So we have basic service sets. It uses single AP to interconnect all associated wireless clients, but clients in different BSS cannot communicate with our own on this environment. So it's a bit related to our SSID. Look at what we have in this place. We have what they call BSA here. That is basic service area. We have another one here. It's only the client that are in this place that can talk to themselves. Clients in this place can talk to themselves, but clients here cannot cross to the other side. But we can decide to link them up. If we decide to link them up, that is going to give us ESA, Extended Service Area, which is not far-fetched from Extended Service Sets. Look at the connection here. This area and this area were linked together using a switch. That's the distribution system now. These people now cannot use the switch to go and talk to the other side. So when you have a union of two or more BSS interconnected by a wireless, by a distribution system, that is our switch. That is called extended service set, and it creates extended service area for you. And clients in each BSS can communicate through the ESS. That should be the way it should be written. So people here can talk to people here, and they pass through the distribution system. So in summary, my BSS creates BSA for me. Basic service set gives me basic service area. My ESS gives me ESA. When I have it set up, it gives me extended service area. These are terminologies we need to be aware of. It's more or less like a coverage. Different SSID, so on and so forth. I don't know if that is clear. Sometimes I struggle to communicate some things. I am more of a practical person. I enjoy practical mostly. Because that one, we do it, we see it at work. There's some theoretical concepts, it's just difficult. They are just difficult to kind of
Hello,
explain.
sir.
So, yes, Prof. Go ahead, sir. Can you hear me?
Just want to, yes, I can hear you now, sir. I just want to ask, okay, so there was a time that they gave me wireless access point in my office, and then I was asking the guy, where is the cable that you connect to the distribution system? No, he said he has connected the backbone wirelessly. And I'm like, I don't think it will work. Well, maybe it worked for some time, but because wireless connections, you're actually not sure of what you're sending or what you're receiving. So what do you think about connecting wireless access point wirelessly? Or is it possible?
It's,
Well,
it's possible now. It works now. That is how they create mesh topology. Let me just show you
okay.
what I'm trying to talk about there. So let's say we have a switch here and a router connected to the ISP. That's connected to the switch. Now there is internet connection in this switch already. We now want to distribute it wirelessly. Some people can connect wired to two other switches or wireless. So if you want to distribute it wirelessly, we can have an AP here. People can connect to this AP. But if we like, we can have another AP here that will also get internet connection from here wirelessly and distribute wirelessly. That is mesh. That's how they create mesh environment. So you don't need to connect this AP directly to the switch or this AP directly to the switch. No, it's only one that will be connected to this. That's the backbone here. All other APs will connect to this AP and pick internet connection and they can distribute.
Okay.
That's the idea.
Okay, that's clear.
Yeah. Is it clear, sir?
Yes, thank you.
Okay. All right, so let's go. Let's move. We'll soon, when I'm done with the slides, we'll take break briefly. Prof, do we have up to 12:30 today, or you have a meeting?
Let's have up to 12.
Okay.
Even without a break.
Okay, that's okay. Okay, so I'm trying to see how I can cover Grant. More of the configuration. That's what I'm interested in. But let's just finish all this story. So when you capture 802.1 frame, what does it look like? I'm sure in CCNA1, you talk about different frame structure, 802.3.1 frame, that is for Ethernet frame, and so on and so forth. But there's something different from 802.1 is 11 is different from 802.3. In 802.11, it has multiple address feeds. The wireless frame structure has multiple address feeds. But in regular frame, Ethernet frame, you only have one where you get your source IP address, destination IP address, source MAC address, destination MAC address. So why do we have more than one in the wireless frame structure? Access point has MAC address. It has to be indicated in this address field. The computers that are connected wirelessly, 1, 2, 3, or thereabout, it has to be indicated in this field. There's a video on the academic platform. I want you to listen to the video, short video on why these address fields are more than one, unlike what we have in 802.3. But basically, what you need to know here, when you see the frame structure of wireless, which is 802.11, you know that this is for 802.11 because it has more than one address field. When you see the regular one for 802.3, it going to have just the regular one, which is just one. For source IP address, destination MAC IP address, source MAC address, destination MAC address. But basically, this is what you need to know about the frame structure. Differentiating the frame structure between the wired and the wireless. And this can be done with Wiresharks. If you capture with Wiresharks, this is what you're going to see. Another thing we need to talk about, I'm going to just summarize this one. How does wireless prevent against collision? Since it's half duplex. When I say it's half duplex, only one person can connect at a time. You think everybody are on the wireless network simultaneously? No. Within a fraction of maybe milliseconds, you are there, you are not there. You are there, you are not there. Another person is connected. So it looks as if everybody is connected simultaneously. It's taking care of everybody as if you are using it simultaneously. No, it's not like that. It's not full duplex. If it's full duplex, everybody can go at once and can come back at once. But once it's on half duplex, it's only one person per time at a time. And that is what you are seeing here. CSMA/CA is carrier sense multiple access / collision avoidance. Carrier sense multiple access / collision avoidance. That is the word for switch. Back in the days of half duplex is collision detection. So what does it do? It's like your traffic warden that controls traffic. You can go, you cannot go. You sit down there, it's time for you to go. Wait for this, and so on and so forth. Wireless are half duplex. And a client cannot hear while it is sending, making it impossible to detect a collision. So how are we going to take care of this problem? Wireless LAN use carrier sense multiple access with collision avoidance to determine how and when to send data. A client does the following. Number one, it listens to the channel to see if it is idle. That is, no other traffic is currently on the channel. Number two, it sends a ready to send, that is RTS, message to the AP to request dedicated access to the network. Number three, it receives a clear to send CTS message from the AP granting access to send. These are all the things going on behind the scene before your computer can connect and send through the wireless network, but you are not aware. Your own is, let me just connect and send, and as long as it's successful, we are good to go. Number four, it waits a random amount of time before restarting the process. Why? If no CTS message is received, if the AP does not clear you to send, you wait, you start the process all over again. But if you are clear to send, you transmit your data. And then what happens again? Number six, you acknowledge all transmission. That is, the AP will acknowledge, you talk to the AP because you are associated. If a wireless client does not receive an acknowledgement, it assumes a collision occurred and restart the process. So what happens is, if you don't hear from the AP that transmission is successful, you believe that your message is involved in collision, and then you begin to resend again. These are all the things that goes on behind the scene because our access point operates in half duplex. That is one of the disadvantages of wireless. That's why sometimes you see on a wireless network, if you plug to LAN, it's going up perfectly. This network is very fast. The moment you plug to the wireless network or connect to the wireless network, the network is very slow. Depends on what is going on your network at that point in time. And this is still beyond this. So we talk about association and the authentication. So what happens between a client and the AP? For wireless device to communicate over a network, they must first associate with an AP or wireless router. Wireless devices complete the following three stages process. Number one, you need to discover a wireless AP. That's why when you want to connect, you first of all go to a wireless and see if there is wireless signal. If you see there, that means that thing has what do you call it? Has discovered that that's an AP. Number two is to authenticate with the AP. And number three is to associate with the AP. I used to think associate come with all the authenticates. I need to confirm that. These are the things three things that will happen before your computer can connect for the first time to the wireless network, because you have to put the password. You have to see that there is a signal. So the moment you launch your computer and on your wireless network, wireless card like this, it's going to probe to see whether there is wireless access point around. And once it sees it, what's the SSID? Do I have what it takes to connect to it? If it is passworded, I can connect to it. Okay, so how do we achieve this association? To achieve a successful association, a wireless client and an AP must agree on specific parameters. Number one, SSID. What is SSID? The name of the network. Maybe Nile, accounting, Nile, computer science, Nile, this, now, depending on whatever you want to put there. We must agree on that. That's why you click that network name and say connect, meaning you agree to that. Number two, password. You need a password for me to authenticate you to connect to the AP. Number three, the network mode. We must have the same standard or compatible standard. I repeat, we must have the same standard or compatible standard, and we've talked about the 802.11 standard. Then the fourth one, security mode. What kind of security or encryption algorithm are you using? If the one I put on me or that I have on me as AP is the one you must have. If on me, I've been configured to use WAP, and you are just trying to use WEP, we are not going to talk. You need to come to my level, and we need to talk at the same level. And then we must be able to agree on the frequency. Which frequency band are we using? All these details, the clients and the AP must agree on this for them to associate, or for them to talk together. If you have issue with any of this, they aren't going to talk together. Are we together, Prof? You're the only one I'm talking to now. Prof, can you hear me?
Yes, I can hear you clearly.
Okay, are you flowing with me, sir?
Yes, I am.
Ahmed, I think Ahmed is still there too now. Mr. Ahmed, can you hear? Are you flowing? Mr. Adekunle, are you flowing? Any question? You just have to bear. This is more of theory today before we get to practical later. Okay. I believe he's hearing me too. So we are not done talking about wireless operation. Passive and active discover mode. So what do we have to discuss here? Wireless clients connect to the AP using passive or active scanning. Active scanning is probing. So what is the difference between the two? For passive mode, AP openly advertises its service by periodically sending broadcast beacon frame containing SSID, supported standard and security settings. So what is happening in this passive mode? We are going to differentiate between the two now. Active mode, wireless client must know the name of the SSID. The wireless client initiates the process by broadcasting a probe request. A probe requests a frame on multiple channels. When you plug an access point, based on the configuration, that is what will determine some of the things the access point will do. For instance, now, if I've decided to hide the SSID, even though this access point will start sending beacons out, it's going to hide this SSID. But what I don't like about this configuration, you still see it showing you hidden network. Why do you need to show me hidden network if I really don't want people to connect to it? So in that kind of scenario, the client does not really know the SSID. So what happens? The client has to probe the AP so that AP can respond with some details. But if the AP does not respond with the details, if we know those details, we can go to the client and put those details by ourselves. So what I'm trying to say in essence is this. Prof, are you still there? I can see you join meeting again. Are you out?
I'm here.
Okay. So what I'm trying to say in essence is this. Under passive mode, the AP gives everything out. Under active mode, it gives only some details out, but the client has to now probe for other details. For instance, now, sometimes when you hide the SSID, how do you configure the client? You go to the client yourself manually and tell the client about the SSID, tell the client about the password, tell the client about other security settings, and then you say connect. So it depends on the configuration that will determine whether the AP will operate in passive mode or operate in active mode. That is the difference between the two. Passive mode is dishing out everything. Active mode is responding to probe requests from the clients. I think we should do one configuration so that we'll reduce this too much talk. Let's do one configuration, then we'll come back to CAPWAP. Is that okay, Prof? Hello?
Yes, it's clear. It's clear, sir.
Let's do one configuration, then we'll go and finish our story.
Okay.
So I want to configure access points here. So let me bring out access point. Wireless. So I want to configure one home router. Let's bring out this home router. So now, how do you configure access point? You use computer to configure access point. So I need a computer. Let me bring a computer out. So when you buy access point, the access point by default comes with default IP address and username and password. Most of the access point. So now in order for me to configure this access point, I need a computer. And this is my access point. I need to connect this particular computer to the access point or to the router. Either router, wireless router, or access point is the same way. So how will I use this computer to configure this access point? Physical connection. Now, let me explain physical connection. The moment you connect this computer to the access point, just tell your computer to obtain IP address automatically. By default, the access point is always configured. Now, I'm talking about autonomous now. Autonomous access point, not lightweight. By default, the router is configured as a DHCP server. So it's going to dish IP address out to this computer. It will give this computer its own IP address. It will give the computer the subnet mask and give the computer default gateway. Who will be the default gateway? Default gateway, that will be the IP address of the access point. So anytime you want to configure an access point, as long as it's autonomous access point, connect to the access point, tell your computer to obtain IP address automatically. Once you see the IP address, the default gateway address, that is the address you're going to use to enter into that device for you to configure it. And how do you configure? How do you use that address? You go to your browser and type the IP address, maybe 192.168.10.1 or what have you. Let's see it at work here now. So for me to connect this computer to the router, that should be a crossover cable. If it doesn't work, I have to change it. Now, if I click this router now, you see that I have internet ports. So if I am bringing in internet connection, that is where I will plug the cable. The other ports are to connect to computers or to switches, because this router is home router. And don't forget what we said about home router. They function as switch because of the multiple ports. They function as router because they can connect to the internet, and they also function as wireless. And right now, we want to configure this as wireless. We can decide to connect computers to the remaining ports later. It will work. So let's click this. So now I have connected my computer to the access point. So let me wait for this cable to turn green. I hope I use the correct cable. Computer to the router. That shouldn't be. Computer to the router. Let me wait small. I think it should be crossover cable. If it doesn't work, then I change to straight through. Yeah, I think I'm correct.
Okay.
So now there is the cable has turned green. I want to see how I can access this particular access point. Don't forget it's an access point. It's a switch and it's also a router. I'll go to my computer, go to desktop, go to IP configuration and click DHCP. And when you click DHCP, you are simply saying obtain IP address automatically, just like what you do with your physical computer. Obtain IP address automatically. So by the time I do this, you'll see that my computer will get its own IP address. it will get subnet mask, and now it has a default gateway. We can further confirm that by going to command prompt and say IP config. Can see it here. It has an IPv4 address. It has a subnet mask, and it has a default gateway. So anytime you connect to an access point and it gives you IP address automatically, the default gateway is the IP address of the access point for you to connect to it. Back in those days when access point were not configured by default as DHCP server, you are the one to go and check the manual, or you go online to find out the IP address of the access point. But nowadays, you get it from the default gateway address. Am I communicating?
Yes.
So now,
Yes.
I can now go to my browser on the computer. See my browser here and type that default gateway address here. So on a regular computer, you can use any of your browser, 192.168.0.1. I hope that is the correct. We can see now that it's asking me for username and password. I think the default username and password is admin. And we are in our access point. Any access point, as long as it's an autonomous access point, this is how we configure it. So what do I need to do in this place? Let me show you something here. Let me show you something here. Look at this place here. It's showing me automatic configuration, DHCP. Which port is that one? That is the internet port that connects to my service provider. It therefore means if I am going to bring down internet connection to this access point, this interface has been selected or configured to obtain IP details from the service provider. Therefore, it therefore means the service provider will have its own DHCP server from the other hand, which could be their own router. I explained this when we're doing DHCP. But coming down, and we can decide to use static. If your service provider is going to give you all the IP addresses needed manually, you use static. If I click the arrow, the drop down arrow, you're going to see that it's going to show me static. I can click static IP. Then I need to have all those information manually from my service provider. And most of the time, they give it to you automatically. That's one. Two, look at this place here. IP address. This is the IP address given to my router by default, 192.168.0.1. I can change it. Don't forget, this is the address we use to enter into the router. I can change it. Look at the subnet mask. I can change it. One more thing you need to see here. Something is activated here for us. DHCP server enable. I can disable it if I want. So the reason why this guy gave my computer IP address automatically from the range of 192.168.0.1 is because DHCP server has been enabled. And you can see down here, start IP address, which they said you should start from .100. The maximum user you can give to is 50. Means the moment 50 people connect to the network, there's nothing we can do again. And all of these details can be changed. You can manipulate. For instance, if I have another DHCP server somewhere on my network, I can tell this access point, I don't want you to give IP addresses to people. Just connect people wirelessly. Relay my DHCP information to them. So I can have a DHCP server on the network that is dishing out IP addresses to user, not my access point. So now this is why when people want to deal with you on your network, they bring access point to your network and plug it to your network and confuse people, the users. Because that's the easiest way to bring a DHCP server to the organization. Just purchase any simple small access point anywhere, change the IP address, send the people to connect to it, plug to the network, and when people connect to it, they cannot browse. These are the first set of stuff you need to be aware here. And all of these things can be changed. So what else do we need here? We can go to wireless and see what's going on about wireless information here. So when I click wireless, see what I got here. I can have the frequency 2.4 gigahertz. I also have 5 gigahertz. So under 2.4 gigahertz, I have my network mode. If I click this arrow here, you can see N only, that is 802.11n. Legacy, we can disable all of this. If I come to 5 gigahertz, we can see we have only N. In some other radio, you'll see N, you see G, a mix of the two, and so on and so forth. But we'll still leave this at auto. So leaving it at auto simply means this access point can relate with any of the standards that your computer is using. And we can see my SSID here. We can say we want to change this SSID to CCNA2. CCNA2. SSID broadcast. Do you want people to see this broadcast? If you want to hide it, you disable. Channel. You can decide to pick a particular channel. Now, when we say 2.4 gigahertz, 2.4 gigahertz have different channels. Channel 1, channel 2, channel 3, channel 4, and so on and so forth. And it is advisable for you, if you have, let's say, multiple access points in your environment, put them on different channels. Like one is on channel 1, the other one is on channel 6, the other one is on channel 10 or 11, so they don't interfere. The access points are now smart nowadays. Just leave the thing at auto. If it's an access point that can support that, when you leave it at auto, they will sort themselves out. And you also have the channel bandwidth. Just leave all of this in as auto. So if they feel like there's somebody beside me that is using a particular channel, and since we are interfering, the other one will switch. And these are the basic settings you need to set here. Basically or majorly your SSID. We can set the password to later, but we have to save. If we don't save this configuration will scatter. So go down and you see save settings. If I click save settings, it's going to save all my settings. Then I can go to another option. I hope it's saved. Things can be funny sometimes. So I can go to another option like what? Wireless security. See wireless security here. What do I want to do in this place? I want to configure password. Is it under 2.4 gigahertz or 5 gigahertz, the first one or the second one? I'm just going to use 2.4 gigahertz. Now, if I click this security mode now, look at different security mode or different encryption algorithm. I can say, okay, I want to use only web. That one is simple. Or I can say I want to use WPA. Or I can, anyone you like, just pick. Just make sure that it's a strong or stronger encryption algorithm you select. So here now, let's say our password is testing 007 hash. No hash. Where's hash? Okay, let's just leave it like that. So what is going to happen when we want to connect to this access point? We need to supply this particular password before we can connect to the access point. If we don't do that, we can't connect to this access point. And that's all we need to do here. Then we'll go down and save our configuration. So what are we doing? We're configuring this access point. Anytime you want to configure autonomous access point, the most important thing are just two. The SSID, that's the network name, and the password. Once you set those two, the others are just optional. Maybe you want to do MAC address filtering, you don't want some people to connect to the access point, you want to filter some people out, and this access point can also do MAC address filtering. You can see it here. I can create a guest network where people that I don't really trust can connect to, or I can do MAC address filtering, where I can say, okay, these are all the MAC addresses I want you to allow to connect to you, or deny. You can do MAC address filtering. There are so many stuff you can do, but the basic thing you can do or you need to do is just set your the SSID and set your password. Once you set these two, your access point is good to go. Are we together? Prof, are we together? Hello, Prof.
Yes, we are.
Can I proceed, sir?
Yes, sir.
Okay. So now we have set up this access point. We have configured it. Let's bring a system out and see if the system can connect to our access point wirelessly. So I'm going to bring a system out. Configure the system to connect to my access point. Click it. I need to put wireless card on this system. By default, the one of packet user doesn't come with access wireless card. I first of all switch off the laptop, remove the casing, the cover. Then this is my wireless card here. Bring it here, and then power hits. And then we can now try to see if this guy can see our access point or our SSID. So go to wireless. So this is our computer. We go to connect and we can refresh. We have done everything right. We should see. Can we see CCNA from the list of the wireless network name?
Yes.
Hello, Prof. Can you see this? We can see CCNA too, right?
I'm here to see it too.
What can you see now? Can you see what I circled now?
Yeah, okay, I can see what you're circled. CCNA2. Maybe it's because of the phone.
Yes, CCNA2. That is the network name we created. Now
Yes.
my card, my computer is seeing it, and this my computer that I brought out is running on 2.4 gigahertz.
Okay.
And we can see the wireless mode is infrastructure because we are using access point. The network is mixed. The radio band is auto. The security, they can support all this range of the security, and we can see the MAC address of the computer. So what do I want to do now? I want to connect to that wireless network. I will select CCNA2 and say connect. By the time I say connect, it brought out this environment for me where I can put the password. So the password is testing 007. If everything is okay, we should be able to connect to this access point. So let's go and see. You see that we are connected. Can we see that?
Yes.
So now the computer on the left, we just use it to configure our access point. So if we don't need it again now, we can yank off this cable and also tell this computer to connect wirelessly. But for the first configuration, the first time you're configuring the access point, you need to cable to the access point for you to configure the access point. And after that, all you need to do is just have your computer, select, search for the network, click it, put the password, click it, put the password, and all of them will connect to the access point. And you have built a simple local area, a wireless local area network. Any other configuration on this access point, they are just optional. Any question on this?
From me, no. I don't know whether the other people have questions.
But it's clear, sir.
It's very clear. It's clear.
Okay. Yeah, Mr. Ahmed, how about you?
Ahmed.
Yes, I'm here, sir.
Is it clear?
Yes, yes.
Okay. So let's just discuss about the next set that is talking about we're going to go to wireless LAN control now, and that is where we're going to end the class. The next chapter is all about this practical, and we have done one already, and I'm going to go do the one that's based on a controller, that is wireless LAN controller. But we need to have some discussion about this, and that is the next part of what the next part of this slide is all about. So let's talk about CAPWAP. CAPWAP operation. So what is this CAPWAP? CAPWAP is an IEEE standard protocol that enables, take note, a wireless LAN controller to manage multiple APs and wireless LAN. It's a standard protocol. It's a protocol that enables a wireless LAN controller to manage multiple APs and wireless LAN. You can see the controller here. One AP is on it, another AP is on it, another AP is on it. Based on lightweight access points, but had additional security with datagram transport layer security. What does that mean? We have a tunnel creating between the LAN, wireless LAN controller, and this is our access point. And because of that tunnel that is created, there is enhanced security on that tunnel as far as security is concerned. And that is what they call datagram transport layer security. It encapsulates and forward wireless LAN client traffic between AP and a wireless LAN controller over the tunnel. That's what the tunnel I told you is created. Over the tunnel using UDP ports 5246 and 5247. Now, when we talk about tunneling in networking or in general is all about a virtual connection that is real. It's virtual, but it's real. And tunneling can be funny. Let me give you an example. Let's say this is me. This is Roland. This is Prof. And this is Mr. Ahmed. I can create a tunnel from myself directly passing through from Prof to Mr. Ahmed. And Prof is not even aware of that tunnel. It's not aware, and we're going to be using it to send data to ourselves, to and fro, to and fro, to and fro. That is the power of tunneling. So anytime you get tunneling, it is wonderful. It's a logical connection between end to end, and you can pass through other devices, and they are not even aware that they are being used to carry traffic to and fro. So it operates over both IPv4 and IPv6. IPv4 uses IP protocol 17, and IPv6 uses IP protocol 1. So why do they always mention all these port numbers? In case you are using firewall, you make sure that these port numbers are not blocked. If they are blocked and you are using this thing, you are implementing this technology, they are not going to work. So if you lock down every port, you must go and specifically open all these ports. If you know you want to use CapWAP technology, or you want to deploy something that is based on that. Another terminology under CapWAP we need to be aware of is split MAC architecture. Split MAC architecture. The CapWAP split MAC concept. Split MAC concept does all the function normally performed by individual APs and distributes them between two functional components. What is the meaning of this? Number one, AP MAC function. Number two, wireless MAC function. What we are simply trying to talk about in this place is this. Wireless LAN controller kinds of separate operation or duty and said, okay, we are going to work together. I am the controller, but there are some responsibility I will give to you as AP. When they ask for those things, you respond with your own MAC address. When they ask for this, I respond with my own MAC address. So they share the workload, even though I'm the controller, even though I'm the one in charge. So for instance, AP MAC function, when it comes to things that has to do with beacons and probe responses, it's your AP MAC that responds to that, as in uses its MAC address to respond to that. When it comes to authentication, wireless controller takes care of that. Packet acknowledgement and retransmission, AP takes care of that. Association and reassociation of roaming clients, wireless LAN controller takes care of that. Frames queuing and packet prioritization, AP takes care of that. Frame translation to other protocols, wireless LAN controller takes care of that. MAC layer data encryption and decryption, AP takes care of that. Termination of 802.11 traffic on a wired interface, wireless LAN controller takes care of that. So it's like a shared responsibility between the wireless LAN controller and the AP. So why they call it split MAC is you are doing something, I'm doing something, even though we work together, or even though I am the controller. That is what is the split MAC architecture is all about. AP MAC, you do something, respond with your MAC address. I do some other things, I respond with my MAC address. The encryption we spoke about earlier, let's talk more about it. DTLS encryption provides security between the AP and the wireless LAN controller. See the AP here? See the controller here. Any conversation going on between the two, you can't capture it and make sense of it because of this security. It is enabled by default to secure the CAPWAP control channel and encrypt all management and control traffic between the AP and the wireless LAN controller. Data encryption is disabled by default. Management information is enabled, but data, that is regular data going, is disabled by default and requires a DTLS license to be installed on the wireless LAN controller before it can be enabled on the AP. So, what are we saying here? If you want the regular data that will be flowing, I'm not talking of management data now. Management data is different from the management data is different from control data. Or management data is different from control data. You need to purchase a license and you need to activate it on your AP. And that is what you are saying here. CAPWAP control, DCL encryption is enabled by default. And when we talk about control, that is management information going between the wireless LAN controller and the AP. But a thing that has to do with data, real information, not about control, that one is disabled. You have to do something to enable those things. Are we together?
Yes, sir.
Okay, we'll soon go to configuration now, and that will be the end. Flex Connect APs. Flex Connect enables the configuration and controls of APs, see, over a wide area network. So it is possible for a controller to be far away from you and is still controlling the AP somewhere. Look at it here now. Corporate office, they have the wireless LAN controller. Then branch office, they have the Flex Connect AP. And there's a tunnel created between this AP and the wireless LAN controller. There are two modes of option for the Flex Connect AP. Number one, connected mode. What do you have in the connected mode? The wireless LAN controller is reachable. The Flex Connect AP has CAPWAP connectivity with the wireless LAN controller through the CAPWAP tunnel. So what happens? The wireless LAN controller performs all CAPWAP functions. That is when the Flex AP is in connected mode. What about when it is in standalone mode? The wireless LAN controller is unreachable. The Flex Connect AP has lost CAPWAP connectivity with the wireless LAN controller. So what happens? The Flex Connect AP can assume some of the wireless LAN controller function, such as switching client data traffic locally and performing client authentication locally. The fact that this guy is no longer reachable doesn't mean the Flex Connect AP is down. It can still perform switching of data information locally. And that is ingenious. But the one we are going to do, you are going to see that we want to set up our APs to connect, to be in a connected mode. It's not about Flex Connect now, because we are going to be in the same local area network. So let's quickly walk through this, then we'll go to the lab. Channel management. So we don't have much to say here. Why? Most of the access points nowadays, you put them on auto, they sort themselves out. But in case you still want to do it manually like they do in those days, if one access point is put on channel 1, the other one should be on 6, the other one should be on 11. Why? So that they don't interfere with themselves. But if you put them on auto, they can auto sense and know that you are too close to me. Let's say I am on channel 1, you are on channel 3, and we are interfering. If we are both on auto, I can move far away from you to 11 or move to something else. And that is why access point nowadays that is how they are configured. They are smarter. They can sort themselves out. So I don't have things to talk about here on this channel because they've been automated for you not to have interference. What about wireless LAN deployment? When you want to deploy, you must do your design properly. You know, I was trying to talk about this intersection. If you don't have a good design and a good interception, you are going to have blind spots. You can see the way they design this thing, and this thing is all about experience. And the type of access point you install in a location also be able to support the numbers of users at that location. There are access points that can support 50 users maximum, access point that can support 100, access point that can support 200, and on and on and on and like that. So you should factor in all of these things when you
Some
are
challenges hearing.
Okay. What about now, sir? Hello, Prof. Can you hear me now? Hello, Prof. Can you hear me now?
Yes, please. Thank you. Yes, I can.
Okay, so we continue?
Yes, I can. I can hear you.
Okay. Okay.
I
So
can hear you now.
I was talking about different access points, their capability, the coverage.
Hello?
Yes, I can hear you, sir.
I can hear you now. I don't
Okay.
know whether, but
Mr. Dekule is saying the
not
network is not
any
friendly
longer.
at all. Can you hear me, Prof? Mr. Dekule, can you hear now?
Yeah, well, I don't know what that means. I, I can hear you now.
Okay. So can we proceed?
Yes, yes, please.
Okay, so I just tried to explain about your wireless design when you are deploying the access point.
But I'm not hearing any
Especially,
longer. Though.
can you hear me, sir?
Not any longer.
Hello, Prof. Can you hear me?
Now, yes.
Okay,
I can hear you now.
okay. So I was talking about the network design when you have a wireless network, a big coverage.
Huh?
You have to
Oh.
design it in such a way that you don't have black spots. What I mean by that, is it black spot called dead spot? I think it's a dead spot or so, whereby you just get to a place where there is no connection at all. It shouldn't be. And that is why you design it in such a way that the signal, the coverage they intersect, so people don't lose connection when they move from one place to the other. So you should be aware of the coverage of the access point. You should be aware of the capability of the access point, as in the number of users you can support, the bandwidth of the access point. These are things you need to factor in. Hello, Prof. Prof, can you hear me?
Hello. Not. Yeah, I can hear you now, but not before now. I can hear you now. I can hear you now. Can you hear me?
I can hear you, sir. Can you hear me, sir?
Yes, sir.
So I want to go to the configuration of wireless LAN controller. Can we proceed?
Okay. Yes, please.
Then we'll now go to the last part. So when you want to configure access points, which we call lightweight access point, they cannot be configured directly. So you need controller. So let's get the controller out. That will be under wireless. I prefer to use 3504 series. This is a wireless LAN controller.
Yeah.
Then I have lightweight access point here. Look at them here. Let me bring out 2 for now. Then I need a switch. Then I also need a computer to configure the wireless LAN controller. Look at all the things I brought out now. I brought out my wireless LAN controller. I brought out lightweight access points, 2, and then a computer. So I will connect the computer to the switch. Then connect the controller also to the switch. There is one more thing I want to bring out. I don't want to connect my lightweight access point now, and I'll tell you why later. I need this lightweight access points here. They need to be given IP addresses by a DHCP server. And we don't have any DHCP server on our network. So we need to have a DHCP server. So instead of us bringing out a router and start doing configuration, we can just bring out a DHCP server. A server that we can just activate. I think I showed this also when we did DHCP. Connect this also to the network. Prof, are you flowing with me?
Yes, please.
Connect this to the network. So what will I do? Let's choose our network address range. Let's say we want to use 200.100.100.0/24. So we are good with that. So what I want to do right now is this. I want to give my computer .2 of this IP address, my server .3, my wireless controller .4, and all these have to be done manually. This is the computer we are going to use to configure our controller. I will give you .2. Why am I skipping .1? I want to give it to my router when I bring a router later. Even though I'm not going to bring a router, I don't need it. So I'll go to the computer, go to desktop, IP config. I'll put 200.100.100.2. Subnet mask, default gateway. We don't have any now, but let's just put it there. Then I'll go to my server and give that server also its own IP address. I'll go to desktop, config. This server I will say you are 200.100.100.3. Subnet mask, default gateway. We go to the wireless LAN controller. Click it also. Now, let me say this. In the real world, you don't click the wireless LAN controller. You use the same way we configure our access point to access it with the IP address. So but here we just click. I'll click config, go to management interface, see the IP address that is there. I will change it to 200.100.100.4. Then correct the subnet mask. Then put my default gateway, which is my router. So what have I done so far? I assigned IP address to my computer that I want to use to configure the wireless LAN controller. I brought a DHCP server and gave the DHCP server also an IP address for my network. I also plugged my wireless LAN controller and also gave it an IP address. Am I done? Nope. This DHCP server we brought in, we have to activate DHCP service on it. Why? Because we want it to give IP addresses to this controller. Later, when we plug, to this lightweight access points rather, when we plug them to the network. So how do we do that? We go to the DHCP, go to services, go to DHCP, and click on. That means we are activating DHCP service. We want to make this server as a DHCP server. So you're going to give us a pool name. We are good with it. It's asking us for our default gateway. We say, okay, the default gateway is 200.100.100.1. DNS, we don't really need it, but we can put 1.4.2.2.2. It's telling us, okay, where do you want me to start as allocating IP addresses? If you look at this, you see start IP address. We can say we want you to start from .10. Okay, the subnet match is correct. Maximum number of users, we are going to leave it there. TFTP server, we don't have any, but we'll look at what I have last year. WLC, wireless LAN controller address. Why do we need this? The DHCP server will give the lightweight access point their IP addresses, their subnet mask, their gateway, and also tell them about wireless LAN controller and say, guys, you need to go and import your configuration from wireless LAN controller. That's why we need to put it here. And that one is 200.100.100.4. That's what we'll put on our wireless LAN controller. And we click save. We are done configuring the DHCP service here. Any question? Prof, are you flowing?
Yes, I'm following.
You are flowing, sir?
I'm following.
Okay. So what are we trying to do now? We want to configure.
I didn't hear that, sir.
I say we want to configure our wireless LAN controller. Are you flowing with all the design so far?
Yes,
Or I lost you anywhere?
Yeah. No.
Okay. So now I want to go and access this wireless LAN controller. But before I go in, let me see if I can ping that controller. I come here, go to command prompt and say ping 200.100.100.4. Because if I can't ping the controller, I cannot access that controller. So obviously we can ping our controller. Beautiful. So now we go to our browser and put that same IP address so that we can configure our controller. So click the browser. So now I will put the IP address of the controller, 200.100.100.4, and click go. So all things being equal, we should be in our wireless LAN controller. So it's the same way you configure your access point that you also configure your wireless LAN controller. You use the IP address of the wireless LAN controller to enter into the wireless LAN controller. Sometimes it takes time here, like a few minutes before it will show us. Prof, can you see what we got? Hello, Prof. Hello, Prof.
Yeah, I can't see anything. I can't see the screen yet.
Are you still using the phone or you are now on the computer?
No, I'm using the phone.
Okay, maybe that's why you're having issue. Who else is there? We can Mr. Ahmed see?
Yeah, okay, I can see Cisco 3500 series wireless LAN controller now.
Beautiful, beautiful. So now, this is the first interface we are going to get when you enter into your wireless LAN controller. So what do we need to do? It's telling us to create username and password. It won't allow you to use the defaults to enter into it. So let's say our username is Nile. Okay, Nile, and let's put our password as CCNA. So when we put this username and password, when next we are coming back to this router, I mean to this LAN controller, we have to use our new username, this username and password. So I'll click Start. Oh, say the format must do not match. Oh, password must complete at least. Okay. Let me see. CCNA. That's not taking this password now. Is it the your? Okay. So now it wants me to do combination of uppercase, lowercase, and special characters. So now I've given my username, I've given my password, so I'll say start. And guess what? I'm inside the wireless LAN controller. And so look at the options that I have in the controller. It's asking me for this name of the system name. That's the name you want to give my controller. I can say Nile, or depending on the location where the thing is. Which country? You select the country. I can't find Nigeria here. Date and time when you set this. Time zone, you set it. Management IP address. You can change it if you want. But if we are good with the one that we got there, we can leave it. Subnet mask, default gateway. If we are good with all those default, I don't think this one is compulsory. So management IP address, how did we come in here? 200.100.100.4. Subnet mask is 255.255.255.0. Default gateway 200.100.100.1. So we click next. What did I put here? I just put the name, time zone, date and time, country, management IP address, subnet mask, default gateway, and I can say next. What is the name of my network? Now, this thing is, I can create multiples later, but let's just change this one and say the name of our network is going to be Nile Uni. Security we want to use, maybe personal is okay. Enterprise, you need a radio server for that. So let's just use personal. So let's say CCNA. CCNA. So now it's asking me for other information. VLAN. Do you know that in controller you can decide to have multiple VLANs? You can have maybe guest VLAN, management VLAN, accounting VLAN. So when people come, you give them different password depending on where the network you want them to connect to. But we're just going to use management VLAN because this controller configuration, just the basic that our church is CCNA. There are other advanced configuration, other configuration stuff. So we say, okay, we're good. Then these are all the details we have set so far. We've created the wireless network. We set up the controller. Advanced settings, do we need to do anything under advanced? No. Now, this is what is all used to be confusing to students. Even me, I was confused at a point. Virtual IP address. Which IP address is this one again? This is an address that just represents the wireless LAN controller. You can change it to anything. You can say 1.1.1.1. It's not an address you use to enter into the wireless LAN controller. So if you are good there, you can just say next, and it will show you these are all the settings you have done. If you are okay with all these settings, you say apply. See, is it complaining somewhere? Okay. It's telling him that it's going to reboot this thing, and after that, all my configuration will be affected. All those long story. I say I'm good with it. Then I'll OK it. So when I'm done OKing it, then this wireless LAN controller will show me that it is now saving my configuration. Why did you time out? Let me see something. Okay, probably this will work different. For my experience using this particular controller, it will just keep on telling you saving forever until you close it manually. So the first time I used this, I had to tell the student that this is where we'll end that class. I couldn't complete the configuration. But another time I used it, I tried to close the page and try to see if the configuration were taking. And I was surprised they were taking. So now it went away by itself. Let's see if we can go back into it. Go to computer, put the IP address, but this time around you put HTTPS, please. HTTPS : //. Now it's telling us to log in. We say we want to log in. Our username is Nile. Our password is password I put, okay, I remember. Wala deo. Controller. It forced us to create username and password. Can you hear me, Prof?
Yes, sir.
The second time we came in, it just asked us to log in, and we inputted our username and password. And guess what? We're inside the wireless LAN controller. So what do we see here? If I go to wireless LAN, we're going to see the wireless LAN that we created, which is Nile_uni. You can see it here. If I go to wireless here, you can go see other information under wireless. Like what? If there are access points already connected to this wireless LAN controller, you see the numbers of APs here. Already, we don't have anything now. It's 0. So now I want us to connect our lightweight access point and see what is going to happen. Give me a few minutes and we'll be done with this lab. So all I will now do is this: carry my lightweight access point, carry cable, connect the cable, connect it to my switch. What does my lightweight access point need? It needs its own IP address. It needs subnet mask. It needs default gateway, and it also needs to know who is the wireless LAN controller. Then I'll click connect to any of the ports. Click again, another one, connect to any of the ports. And this is the beauty of wireless LAN controller. I will show you something now. Let's wait for them to finish. Now, this is not going to, I forgot something. I need to power the lightweight access point. I'll go click the lightweight access point. Just attach what do you call it, adapter, and that powers it. Go to the other one, connect the adapter, and that powers the lightweight access point in packet tracer. And let's see what's happening. Now, I need your attention. I want to show you something. If I point at the lightweight access point right now, I need you to see something here. I don't know if I can circle it for you to see. I cannot do it at the same time.
Right.
Okay, if I point at the lightweight access point, can you see something under, let me see. Cap warp status. Prof, can you see cap warp status? What did you see? What do you see there?
It's up now. Maybe it will come through.
No, cap warp status is showing not connected.
I'm not seeing any pull down yet.
Okay, you didn't see. Can any other person
No,
see?
I saw it before. I saw it before, but it's off now. Okay, I can see it now. So cap WAP status. Yeah, it said not connected. Yes, I can see
Okay,
that.
so that's what you see now. So let's wait for it and see later. The other one too is going to say CAPWAP status not connected. Oh, the other one is connected. Can you see what is on the other one?
Yes, yes, connected to 200, 100, 104.
Then what else
It's
did you see on
connected.
that? Did you see the SSID for the
9 unit.
beautiful? So now if you come back to the first one here, you're going to see similar stuff. This one is also connected. Can you see it's also connected?
Okay, yes.
Can you see?
Yes, it's connected.
Now, this is the beauty
Yes.
of wireless LAN controller. If I like now, there's another location. They say, they need internet connection, blah, 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 blah. Okay, no problem. We just go and get another lightweight access point, bring it out closer to the location where we are talking, where they need internet connection, and just plug it to our network. Don't need to do any configuration, and they will pick up their configuration from wireless LAN controller, and users can now connect to that, to the lightweight access point, and they begin to and they become part of the network. So let's see whether this one too will get the configuration. No configuration, don't need to do anything, just plug it to the network and you are good to go. So you can keep on adding access point, adding access point, adding access point, adding access point, lightweight access point. Wireless LAN controller will keep on doing its work. They get the configuration from it, people connect to it, and then they begin to browse through that particular access point. So you can extend your network with that.
Hello?
Yes.
Hello, sir.
Can you see the new access point we added? It has not,
Yes,
it's
I
not
can.
yet connected. Can you see the CAPWAP status?
Yes.
So we wait for it to connect. So we didn't do anything on this lightweight access point. We only plug it to the network as long as our wireless LAN controller is up and running. So before this one will connect, let's go back to our controller and see something there. Before, we saw that it didn't have any AP connected. So let's go back, let's refresh and see if there are APs.
Yeah, so there is an access point now.
Did you see the numbers of AP?
Yes, well, there are 3 lightweight access
There are
points.
3 lightweight access points now. Now they have all been connected. So if I like now in the real world, you can just click this access point and see all the clients connected to that access point. If you are managing your access point from this wireless LAN controller, if one goes down from the controller, you can know that so location is down. The access point is not working again from your wireless LAN controller. So you keep on adding, you keep on adding, you keep on adding. You don't need to do any configuration. That is the beauty of using wireless LAN controller on your network. Is that clear, sir? Hello, is it clear? Prof, is it clear?
Yes, for me.
Yes, it is. But just one quick thing, the lightweight, maybe I missed it while you were introducing it. The lightweight access point, how is it different from the regular access point?
They don't have brain of their own. They need a controller to get
Okay.
the information.
Okay, so it's not really no routing, no nothing. Just
Nothing. Yes, you
just
you
joining
can't
terminal.
configure them directly. You just plug them to the network and then configure your LAN controller, and then they pick the configuration from the controller.
Okay. It's there.
So that is how you set up this. Now, the last thing I would have love to do is to now bring computers here and configure them to connect to this lightweight access point. I've tried this. For some reason, it doesn't work. They don't connect to the lightweight access point. I don't know what I'm missing here. So that's the only thing I've not been able to do with this my design. But to set up the controller, to set up the lightweight access point to connect to the controller, the access point getting IP addresses and all of that works perfectly. So
Okay.
this is just the only challenge. But in the lab, you are going to see the lab I'm going to send to you their own works. So I have to sit down with this to find out what am I missing that my computer can't connect to my lightweight access point in this particular design that I have in the packet tracer. So that's the only thing left. But once you have it up and running and you can see the signal, then you're good to go. Let me try it once again, see. You remember when we were working with autonomous, we saw the signal?
Yes.
So for this one, for some reason, I don't see the signal. I don't see the signal. I don't know why. So for lightweight, this has not worked for me. To connect the host to the lightweight in packet tracer has not worked for me. So I'm still trying to do research on that. So that's the last part. Also, you can decide to connect to standalone, but standalone is not scalable. It's not scalable for big organization. You have to set up wireless LAN controller and lightweight access point. That one is scalable for big organization. You can manage it easily. So that is that and down. Any question before we go to the last part? We'll soon be wrapping up.
No question from me.
Okay. Okay, so the last part is the threat to our wireless network and how we can mitigate. Of course, we've talked about mitigation already. It's just to re-emphasize. Wireless security overview. A wireless LAN is open to anyone within the range of an AP and the appropriate credential to associate to it. Attacks can be generated by outsiders, disgruntled employees, and even unintentionally by employees. Wireless networks are specifically susceptible to several threats, includes the following: interception of data, wireless intruder, denial of service attack, rogue APs. These are all the attacks you can deploy against wireless. So what is DOS attack? We talked about DOS attack yesterday. Wireless DOS attack can be the result of the following: improper configured devices, a malicious user intentionally interfering with wireless communication, accidental interference. To minimize the risk of a DOS attack due to improperly configured devices and malicious attacks, harden all devices. This is key. You need to know how to do this. When you say harden devices, one of the way you harden your device is just to update the OS. That's one way. Block all the ports that you don't need. Keep your password secure. Create backups and ensure that all configuration changes are incorporated off hours. When you want to make any change, it should be when people are not in the office. Another threat is rogue access point. What is a rogue access point? I can bring my own access point and plug around your office. It has become a rogue. It's not supposed to be part of your network. A rogue AP is an AP or wireless router that has been connected to a corporate network without explicit authorization and against corporate policy. Once connected, the rogue AP can be used by attacker to capture MAC addresses because people want to connect to that, capture data packet, gain access to the network resources, or launch a man-in-the-middle attack. If only what people are looking for is internet access, I can give them internet access, but I'm already in the middle, capturing whatever is going out and coming in. A personal network hotspot could also be used as a rogue APs, like my phone now. I can on hotspot. For example, a user with secure network access enable their authorized Windows host to become a Wi-Fi AP. Even your regular computer can be activated as AP. Mitigation. To prevent the installation of rogue APs, Organization must configure wireless LAN controller with rogue APs policies. Do you see that? And use monitoring software to actively monitor the radio spectrum for unauthorized APs. If we know that we don't have more than 3 APs in our organization, and we launch a software, your regular computer can do that for you anyway. You are seeing signal AP1, AP2, AP3, AP4, AP5, and you know you don't have more than 3. You may
Now
have.
can you again?
Okay. Can you hear me now, Prof? What about now? Hello, sir. Hello. Prof, can you hear me? Hello. Okay. Mr. Adekunle said he can hear me. He said he can't
I
hear
can hear
me.
you too. I can hear you too.
Okay, that means it's from Prof's end.
Not hearing you.
Prof, can you log out and log in? Let's see if you will hear. Prof. Hello, sir. Hello, Prof. Can you hear me?
You went off for some time. I could not hear anything again.
No, I have not been talking now. I'm waiting for Prof. Hello, can you hear me?
I was taken out by small device.
Okay,
So
can you hear me?
Can you hear me? Yes, I can hear you now, sir.
Okay, so please, can you mute one of the devices? It can come back.
I just mute both.
We'll soon be done. Been a long story today. So can I continue, Prof? Hello, sir.
Please go ahead, sir.
Okay, so man in the middle, we talked about that man in the middle attack before. The hacker is positioned in between two legitimate entities in order to read or modify the data that passes between the two parties. A popular wireless man in the middle attack is called evil twin AP attack, where an attacker introduces a rogue AP and configured it with the same SSID as a legitimate AP. Defeating a man in the middle attack begins with identifying legitimate devices on the wireless LAN. To do this, user must be authenticated. After all of the legitimate devices are known, the network can be monitored for abnormal devices or traffic. Now, it's not enough for you to just say you have wireless network. People can connect. You must do serious monitoring so you don't have rogue AP coming in. Because most of the time, all people want is just internet access. And as long as they have internet access, they don't bloody care who they connect to. So they will be going out and coming in and they're happy, but the threat actor is already harvesting data. So monitoring of wireless network is very important. And this is one of the areas where your controller can help you. So securing your wireless, how do you do that? One of the things you can do is you can hide your SSID. Don't display your SSID. That can help. You can do MAC address filtering. Just put in the MAC addresses you want or the ones you don't want. That also can help to secure your network. And of course, you put passwords. Don't ever leave your wireless network open. You can put password. You go for a very strong authentication, like you have WP, WPA, WPA2, WPA3. The longer you go, the more of this encryption, the better the strength of the password. So different encryption algorithm. Like now, it's good for you to go for WPA3 because this is the next generation Wi-Fi security. You always go for advanced authentication method because they are better secure than the old one. So even if somebody wants to try to hack into your network or to crack the password, they have to work hard. Okay. So for home users, you see we have different options. We saw this in when we configure the access point. You can decide to leave the thing open by disabling. You can go for web, WP personal, WP enterprise. When you go for enterprise, you need a radio server. But then look at what we got here. WPA2 personal. PA2 is more secure than WPA. So it is advisable you go for WPA2. If tomorrow now you find another access point that has a stronger encryption algorithm, you go for that, or authentication method, you go for that. Even under the WPA2, there are different algorithms under it, encryption algorithm under it actually. You have AES, you have TKIP. Which one is stronger? You go for a stronger one. AES is stronger than the TKIP. You go for a stronger encryption algorithm. These are ways that you use to secure your wireless. And if you are using radios, that one, you point your access point to the radio server. So it therefore means people that will be authenticated, they need to be, the radio server is going to be the one taking care of all of this user that needs to be authenticated. And so these are just some of the stuff we need to talk about. So WPA3 is out. So if I have it on any of my access point, I would rather go for WPA3 for personal. And if I want to use radio server on my network, I will use WPA3 enterprise. Don't ever open your network without password when you don't have any authentication. It's not the best for you. And then the last thing I think they talk about how IoT onboarding. What does this really mean? It doesn't really have much to do with our discussion. It uses device provisioning protocol to quickly onboard IoT devices. I don't have experience with IoT devices. I cannot say much about that. So basically, that is the end of the wireless LAN threat and mitigation. Any question? Any question?
Not from here.
Okay.
But the recording will be very important because